Okay. Well, good morning, everybody on the West Coast, and good afternoon, everyone on the East Coast. My name is Brandon Goshi. I'm from the Metropolitan Water District of Southern California, and I'm going to do, I guess it's the first of the case studies of how we implemented and evolved some of these decision-making processes or these uncertainty planning processes into the planning at the Metropolitan Water District of Southern California. It occurred to me when I was looking at the title that it says adaptation decision making, and I think as a preview that might be one of our issues in communication. Is really this is decision support and not decision making, and I think that that helps to clarify uh, can help to clarify a few things. So as an overview, I'm going to talk a little bit about Metropolitan Water District and our planning scope, uh, and then I'll talk about the evolution of these different types of uncertainty planning as they pertain to Metropolitan Water District's water planning, and then share a few lessons learned along the way. And it's been a long way. We've been doing this type of planning since really the early to mid 90s. And so it's been quite a while. So Metropolitan Water District and our planning scope. So Metropolitan is not a water retailer or a water purveyor per se. We're a regional water wholesaler, and I think the largest in the nation. We have 26 member agencies who can buy water from the Metropolitan Water District. Some of those member agencies are cities and direct retail water purveyors. Some are municipal water districts or mid-level wholesalers that then deliver their own supplies and our water supplies to their member purveyors. Within those 26 member agencies and within our region in Southern California, I think there's about 185 different retail water purveyors. So different water governance going all the way down to the retail level within that 5,200 square mile area in Metropolitan Water District. There's close to 20 million people in the Met service area. We're governed by a board of directors with 38 members. So we have a 38 member board of directors representing our 26 member agencies. And the region serves somewhere between 3 to 4 million acre feet of annual retail level demands. Metropolitan's imported supplies, or Metropolitan's supplies, comprise roughly half of that regional total. Where does the water for Southern California come from? This graphic basically shows an average kind of breakdown of the major water sources and the percentage of that 3 to 4 million acre feet that is served by these different areas. So within Southern California, there is about half of the water demand served with locally developed resources. One of those locally developed resources is the city of Los Angeles's Los Angeles Aqueduct, which is really an imported resource, but developed by a local agency. And I did want to point out that in Rob's presentation, he talked about the city of Los Angeles. City of Los Angeles is one of our larger member agencies. They're a direct retail city water provider, but we, the Metropolitan Water District, are not the city of Los Angeles, so I wouldn't want to confuse the two for the purposes of this presentation. So other sources of water in the local area in Southern California: groundwater, recycled water, some small surface water diversions, and structural conservation efforts in water use efficiency. Metropolitan was actually formed to import water from the Colorado River. And you can see over on the right side of the graph, about 20% of the region's water comes from diversions and imports from the Colorado River. And I want to point out that the watershed for that Colorado River comes from the upper Colorado River basin. So east of the Rockies is where that water starts and flows down through 7 states that use Colorado River water. And even within California, there are 7 parties, different parties. Metropolitan's one of the parties that have entitlements to Colorado River water in California. Metropolitan's also part of the California State Water Project. And so you can see coming from the north of California, large aqueduct system, a I think it's 260-mile aqueduct system that brings water down from Northern California and comprises about 30% of our total water supplies. Metropolitan's one of 29 state water contractors who have contracted to pay for the infrastructure and to receive the water supplies that are available from that state water project. So point here is a wide range of areas and watersheds that comprise the sources of Metropolitan and Southern California's water supply, and um, and a lot of parties involved on the Colorado River, in the state of California, and within our service area. You may have heard about the, I think I'll call it a preview of climate impacts that are happening in Southern California. When you talk about extremes that are being observed that indicate what future climate might look like, California, Southern California is getting a good share of them. And this graphic shows some of the headlines that have been coming out since the 2020s. One of the largest droughts and driest years in history, followed by one of the wettest years and biggest snowpacks in history. And, stories about Lake Mead and the Colorado River drying up, and then stories about Lake Mead and Lake Powell going up 60, 70, 80 feet in a single year from a single winter. Here's some pictures that I think are kind of interesting. Over on the left, an indicator of some of the snowpack during the driest of years. I think that's 2021 or 2022. And then right below it, some of the snowpack at one of the ski areas in California. And you can see the height of that snowpack just there near the parking lot. I'm assuming that that gentleman is 5'7". So quite a bit of snow there. Even saw some snow in the semi-arid desert region of Southern California. You can see the palm trees covered with snow there. And we've had wildfires, we've had record temperatures and flooding, both urban and within the watersheds. All of these pictures were taken in the last 3 years. And so that's a pretty impressive range of climate impacts that do affect water resources that we've seen in California. So how do we plan for the uncertainty associated with this? And my presentation today is really talking about the evolution of uncertainty planning for our region that we've really been implementing, improving, evolving since the 1990s. And so here's a very simple graphic of the modeling and analytical approaches that we've taken over that, say, 25-year period or 20-year period, right? We started back in the 90s developing what we call an index sequential simulation, water resource simulation model. And really, I think the way I think about that is that is a deterministic model that models the availability of our water resources and our demands on a simulated basis under what we would consider here in this uncertainty planning setup as kind of a assumed known range of hydrologic probabilities and outcomes, right? Right around the 2010s, 2010 timeframe, we started working with the Rand Corporation and Rob Lempert on implementing robust decision making. And so we went down that path of robust decision making for probably about a 7-year period, I think. Maybe a little less than that, 5 to 7 year period. And then most recently, we have kind of changed our approach to incorporate a scenario planning approach as opposed to, or in addition to, I should say, that robust decision making. So that's kind of the evolution as we go. And I'm going to talk a little bit about the underlying, how we make this evolution. So I started talking about this index sequential model, and this model is called IRP Sim, right? IRP, Integrated Resources Plan Simulation Model. And so it's a water resource simulation model that incorporates and models over a range of hydrologic outcomes information that is estimated and taken from all of the areas that affect our water resources. So whether it's that range of local supplies that we had, the groundwater, surface water, the amount of conservation savings that's been embedded into the retail water use, our retail level demands, which is built on housing and demographics and water use habits. Our Colorado River forecasts, which incorporate, hydrologic change, our sales model, the state water project forecast model, and a wider range of our available storage management programs. Metropolitan has invested billions of dollars actually in the last 30 years in a wide range of portfolio of storage resources, both large surface water reservoirs, groundwater programs, groundwater storage programs, and partnerships with those that can help to manage water. All of that information is rolled in to IRP Sim, that simulation model, to see, and that model has the ability to simulate the balance of these supplies and these demands over a range of different uncertainties and hydrologic outcomes. That IRP Sim model is, I think I'm characterizing it here as being deterministic and really the first step in the evolution, but it actually forms the building block for the main analytical tool that then is employed in these more complex decision-making under uncertainty kind of techniques. And so this model was pretty complex. It has 30 inputs, 30 different supply sources, 10 different demand categories, over 20 storage and transfer programs, 1,000 supporting variables, 24 operational stages that mimic how we operate each one of these programs. It simulates over 50 years our water supplies, over 80 known hydrologic traces, the historical hydrologic index sequential outcomes of weather. The most important thing about this is it's comprehensive, and it can do all of these calculations in about 8 seconds. So that's huge when it comes to incorporating this kind of information in a framework like RDM. So we took that model and built it into providing information under this robust decision-making framework with the collaboration with RAND. And so that was one of the evolutions that we did, was incorporating this robust decision-making. And in that process, we expanded the range of uncertainty under which that IRP Sim model simulated our water resources to include this experimental design, or this all of these different factors and ranges of uncertainties. So on the left, you see the different factors of uncertainty that were incorporated into the water resource simulation model. So different demographic changes, the uncertainty of how many people, what kind of housing, where that housing is going to be within Southern California, all affect the amount of water that we need to provide, provide in the future. You see climate conditions as a factor, and we used information from global climate models, 12 different climate scenarios that were used to basically expand that what we formerly thought as a known range of hydrologic outcomes, and basically impose the changes that were being modeled in those global climate models into the simulation. Then we had ranges of uncertainty on the development and the yields and the effectiveness of some of our different water sources, whether they were the state water project up in Northern California or the yields of the local projects, and also the implementation timing of new projects that were slated to come online. So those were the different uncertainties that were done. And within this experimental design, we basically ran a bunch of what-if scenarios varying that different outcomes within the ranges of uncertainty for all of those variables. And so that gave us a wide database of results in which to see. And this graphic just shows that RAND had a good analytical framework for us to use to be able to incorporate this kind of information and use something called scenario discovery to figure out where we were starting to have difficulties meeting water supply reliability. So in our RDM approach, we looked at close to 7,000 different combinations of uncertainty. So it's kind of like thinking about it as we looked at 7,000 what if scenario models, and then we used a statistical method to find out when we failed to be reliable. So when we had shortages or surpluses of water on an annual basis out through that 50-year period, and when our regional storage levels um, got to low levels that would cause a regional concern, we kind of flagged those for the scenario discovery as when these things are happening, let's figure out what are the combinations of the uncertainties that are causing these things to happen. So that was the RDM, approach there. And I think before I move on, I want to say that it's very comprehensive and very complex. But as you can imagine, it's also very difficult to explain and interpret those results, particularly to a governance and customer structure and partner structure that I described Metropolitan as in. So in our last kind of major regional planning effort, what I call the 2020 IRP, we actually evolved everything that we learned during the RDM process, with regard to how to characterize, our XLRM framework that Rob had talked about, and moved it into what I consider to be a more visible and interpretable DMDU type of process, and that's scenario planning. So again, the RDM, very comprehensive, but very difficult to explain, I think. And we ran into real world examples of that. It was difficult to explain some of the results and how to translate those results into something workable. So we went through a big public process and with our member agencies to identify the major drivers of change or drivers of uncertainty that affects our supplies and demands. And then we incorporated, with the help of a panel of climate change experts, some characterizations of moderate or severe climate change into that framework. And so here's kind of the drivers that we looked at in forming our scenarios for analysis. And so we had climate change, looking at the range of gradual versus rapidly rising temperatures and erratic precipitation. And really that, the impacts of that were looked at by looking at sets of models that were done, GCM models, under two different emission scenarios, RCP 4.5, RCP 8.5, to draw a range of possible or potential climate change outcomes that we might be facing. We also looked at regulatory issues as a main driver of uncertainty, and also the demographics. So similar to the RDM analysis, demographics, which are driven by a slower economy with moderate population growth, has lower demands in the future. A strong economy and strong population growth has strong demands in the future. I see you, Alyssa, so I'm going to rapidly hone in on the landing strip here. So we went through a big process to determine these major drivers of change, and essentially developed a little matrix here of 4 scenarios that explored the edges of the uncertainty that we may be facing. But again, it's with kind of well-defined and things that we can talk about, pictures there. So, going through that analytical framework, we basically developed those scenarios and characterized the uncertainty, modeled that uncertainty using that IRP sim simulation engine, and then basically showed how our frequency of shortages or our incidences of low storage ended up, same like we did in the RDM process, out through 2045 for each one of those scenarios. Then the next step is to use that information to identify what potential actions we could take or invest in to minimize that supply and demand gap, and are trying to incorporate the tenets of basically adaptive pathways in terms of guiding our thinking of how we implement this. And so lessons learned in terms of this analysis is that there's a balance between communication and transparency, especially when you're talking about a big stakeholder group, um, balancing that with analytic rigor. So you want to do as much analytic rigor as is needed to support your decision-making process, but also keeping in mind that you need to communicate the hows and whys of why that worked out. So I've personally found complex approaches and findings are challenging to communicate and gain understanding with decision-making bodies. And so while Metropolitan was able to incorporate a more technically complex method in RDM, I think we're finding that scenario planning is more transparent and helps to increase collective understanding in a decision-making process that's going to take place through time as we adapt to the changes that are being explored through this process. And I think that's my last slide, and I think I have time for questions.
Yes, you certainly do. Does anybody have questions for Brandon about his presentation? You can raise your hand or you can pop it in the chat. I'm also looking at the Miro board. There's quite a lot of work that's been done in that today, and I definitely appreciate that. Under the implement section and the sustain section is a little sparse under the groupthink area. So definitely I would suggest that you take some time to add those things in there. Julie, I see your hand is raised.
Yeah, great. Well, that really interesting. Quick question. When you said you kind of came up with those 5 categories, I think they were climate change, political, economic, demographic, and regulatory. I'm wondering, were there other categories that came up that you decided not to have? And then kind of a question for the whole group, thinking regionally, would those same categories kind of fall within the Delaware River Basin as well? So Brandon, were there other categories that were considered? And then I would be curious hearing from others too, if they would have other ones to add.
Yeah, so we developed those through a pretty large interactive process with both our member agency technical staff and with regional stakeholders and the public. And really, it's under the guise of drivers of change. And so that process really helps you identify the biggest uncertainties that affect your water resources, and then helps you fit it into this scenario planning where you're really looking at the things that move that supply and demand balance the most, combined with the things that you want to plan for, right? So you're kind of planning, identifying and planning for those things and fitting it into the largest movements. And then, and we do have a little bit of difficulty with this, knowing that some of those smaller categories that have smaller changes will be happening at the same time, but won't be moving the needle as much. So what you can glean from that analysis is that, there's a lot of things that might drive demands to be lower. It's best characterized by the uncertainty in demographics. That's the biggest driver, but other things can affect it. But really the important thing is, how does your water resources challenge or cost effectiveness of programs change with those lower demands, if that makes sense. So that's so yes, there are more categories, and they're considered that way within the bounds of the uncertainty analysis.
Do others have categories that they think would be either maybe should be substituted for the Delaware River Basin or added, or things that are maybe not necessarily as applicable in that basin? Maybe it seems like we have similar challenges across the US. Maybe that's what we're hearing. Yeah, all the categories are applicable to the Delaware River Basin. And that's, it's a good thing because we can all talk about it across the US, but definitely is means that we still have a lot of work to do, it seems like. So good. This is great. Thank you, Brandon.